Hello students, welcome to another video tutorial. Today we will discuss about one of the basic practical of class 12, that is Wheatstone bridge. So we'll do the entire practical one by one, but before that we need to understand the theory. So let us try to understand the theory first, and then we'll move back to our practical lab, and then we'll do the practical, and the last part will be our calculation part. So let us go and try to understand the theory of the practical.
Okay, so our target today is to do this experiment that is called Wheatstone bridge. So we'll do the serial number 1 practical. So let us jump to that experiment. So it's in page number 10. So page number 10, yes. So this is the circuit diagram. We will have a unknown resistance X, and this is basically typical wire. It's made up of a wire, and a known resistance RB, it's a resistance box, and a bridge, it's called meter bridge, and it's a 1 meter long bridge. It's basically, bridge means a wire. There are two terminal A and B. You will see everything in the practical lab, and we will connect these by wires, and there is a power source which is called B, and a key, and a rheostat, and a galvanometer. So this is the basic circuit arrangement. The basic circuit arrangement we'll do in the laboratory, but first we want to understand the entire theory. Now the question is, in which principle the meter bridge work? The meter bridge work with the principle of Wheatstone bridge, as we know. Now as you can see that there are few things we need to know from here. First of all, this RB and this unknown resistance X and this L and this 100 minus L, these four resistance makes one Wheatstone bridge. So we are giving name R1, and this is R2. So according to the concept of Wheatstone bridge, we can write that RB, we are just calling it R simply, by R1 equal to X by R2. Okay, now what is the value of R1? Now if the resistivity of this wire, we have, as I said, we are using a simple wire AB. So if the resistance per unit, the resistivity of this wire is rho, then we can write R1 equal to rho L by A. And what is R2? R2 equal to rho 100 minus L by A. So we have to find out R2 by R1. Okay, so we can write X equal to R2 by R1 into R. Now what is R2 by R1? See, R2 by R1 will become 100 minus L by L into R. Okay, so we have to find out the length at which we are getting the null point, that means the balance condition. So our job here is to first make the circuit. We have to make entire circuit, and then put a certain resistance in the resistance box RB. Suppose RB will take 2 ohms or 3 ohms or 4 ohms likewise, and then we will find out the length at which we are getting zero deflection in this galvanometer. So these are the steps we will do one by one. The details discussion is given in the PDF. You will read the PDF, you will understand everything. Okay, so this is our observation table. We have to fill up this observation table. Okay, now we'll suppose RB will take 2 ohms, 3 ohms, 4 ohms, 5 ohms, and we'll find out the length. Suppose this is 40, 50, 60, 70, likewise whatever we'll get, we'll put the value, and we'll find out 100 minus L. The values will fill up over here, and we are going to calculate with this formula, and we're going to find out the unknown resistance. So this is the work we have to do. Now another part of this experiment is to find out the cross sectional area, and then we have to find out the resistivity of the sample wear. Now what is the sample wear? Sample wear, as I said, we are going to use an unknown resistance that is called X. Now X is basically a short wear, nothing else, it's short wear, it's called sample wear, and we have to find out the diameter of the sample wear by using a screw gauge. And once we have done the diameter, we have to find out the cross sectional area A, and the formula is A equal to pi d square by 4. So this is the formula by which we are going to calculate the cross sectional area of the sample wear, and then we have to find out the resistivity or resistance per unit length of the unknown resistance X. Okay, so what is the theory behind that? So let us try to understand the theory. As I discussed, R1 equal to this, R2 equal to this, and then we will find out this equation. So this is the equation we are going to use, as I discussed already, and for rho it will be rho equal to R A by L, and L is basically 0.5 meter. Okay, this is given, the length will be 0.5 meter, and cross sectional area I have to find out. How I can find out? I can find out by this equation, as I said, A equal to pi d square by 4. Okay, now diameter I have to find out by a screw gauge. So there should be another table. So what is the table? This is the table, and we have to find out the diameter of the wear by filling up this form, this table. So main scale reading will fill up. So for a wear, main scale reading, most of the cases main scale reading will be 0. So circular scale reading and total reading will write, and we have to find out the diameter, and then we have to find out the area, and then we have to put the value, and using this equation we will find out the rho. Okay, so these are the thing you have to do. So please remember these two equation, this equation and this equation, because these two equation are the working equation of this experiment. Okay, we need to know very clearly of this expression. So procedure I'll not discuss because we are going to do this experiment practically. So let us jump back to practical lab, and we'll do the experiment, and then we'll return and do the calculation part.
Now I hope the theory portion is clear to you for this practical. Now what you have to do, you have to arrange the circuit and you have to do the things practically. Now as it's locked down, you cannot go anywhere, so I'll do the practical right away. You'll see what I'm going. Now let us see what are the apparatus I have. I have a galvanometer, I have few connecting wires, okay, and this is the resistance box, this is the key that I have, and this device is called meter bridge, and this is the jockey that I'll use. Okay, and this is our power supply, and this is the multimeter. I'll use this for the checking purpose. Definitely it is not needed for the students, but if something was wrong, I'll use this device. Okay, so let us try to arrange the circuit properly, and this is the circuit that I have printed the PDF, and this is in front of me. So I'll just try to arrange the circuit using the connecting wire, and I'll check it whether the circuit is working properly. Now first thing what I have to do, I have to take the terminal A and B. So this is the wire, and this is terminal A and this is terminal B. So in this device, this is the terminal A and this is the terminal B. Okay, and this is the jockey. So what I'll do, I'll connect this A terminal with the power supply. Okay, so as you can see, this is A part terminal is connected with the positive terminal of the power supply. So I'll just connect this part of this A with this positive terminal of the power supply. So let me just connect it. Now as you can see, the negative terminal of the battery is connected with a key. So I'll request Karthik to connect this negative terminal of the battery with the key. So this should be connected over here. Now this part, as you can see, the next part, the key is connected with a rheostat. Okay, so this part of this key will be connected with the rheostat. Now you see, this rheostat is connected with the B terminal. Okay, so this terminal will be connected with this B terminal. See, this is the B terminal. Okay, so this part is complete. Now what I'll do, I have to connect this resistance box, this unknown resistance, and the galvanometer. So let us just connect this unknown resistance. So in this point we'll connect the unknown resistance. See what is the circuit configuration. So this is a metallic plate. So this, if this part is B, this part can also be considered to be B, and as you can see, with the B terminal, this resistance box is connected. So we have to connect this resistance box in these two terminal. So I'll request Kartikda to connect these two terminal with the known resistance RB. This will be connected over here, and this will be connected over here. So as you can see, we have just connected this resistance box. So this is the resistance box we have connected with this terminal. Now what I have to do, we have to connect this X. This X is the unknown resistance. Now we have this unknown resistance X over here. So we have to connect these two terminal with these two terminal. Now I'll request Kartikda to connect this unknown resistance with these two terminal. Okay. So as you can see, this unknown resistance is also connected over here. Now our last part is to connect this jockey. So this is the jockey and this is the jockey terminal. So this is the jockey terminal. This junction is called jockey terminal. So this point is actually connected between the resistance, known resistance and unknown resistance. So see, this is the known resistance point and this is the unknown resistance point. So this middle point is the jockey terminal. We have to connect this jockey terminal with via galvanometer. So we have to connect this via a galvanometer. So I request Kartikda to connect this terminal with a galvanometer, and then this terminal will be connected with the jockey. Now see, in the jockey you cannot add any wire with it, okay, but rather there is a metallic rod and here we can connect this connector wire. So this is basically the jockey terminal for this meter bridge. So this is the meter bridge. We have to connect this jockey terminal with this. So this will be connected with the galvanometer and this terminal will be connected with this. So we have connected this jockey terminal. As you can see, Kartik have connected this jockey terminal with the galvanometer and the galvanometer is connected with this point as mentioned over here. So I hope this part is also clear to you. Now our work, our circuit is completed. Now we have to check the circuit, we have to test the circuit, and I hope everything is working properly. So let us see whether everything is working properly or not. So let's hope for the best. Now we have turned on the circuit. See, the indicator is red. That means, and here also you see the voltage is 4 volt. Okay, so this voltage is given and supplied to the circuit. Now I'll check whether this circuit is working properly or not. Okay, so whenever you have turned on the circuit, you have to make sure that none of the wire is crossing each other. So as you can see, none of the wire is crossing each other. So if it is, then you have to correct it so that none of the wire are crossing over each other. So to adjust, okay, so we have to adjust. Now it's okay. Now we'll check whether the circuit is deflecting. Now the rule is, rule number 1, whenever you have the jockey, you will connect it with terminal A, and you will see whenever you're tapping it, you'll see the deflection. See, you're tapping it and you'll see a deflection in the left hand side. See, whenever tapping it, I'm seeing on, this is way I tap, and whenever tapping it, it's showing a deflection. Okay, now previously it was deflecting in the left direction. Let us see whether in this terminal B it is showing the direction in the right. So see, it will deflect in the right direction. Okay, so whenever I am connecting in B, it is showing in the B opposite direction deflection. That means our circuit is working properly. Now we have to find out a specific point where the galvanometer will show no deflection. So now point number 1, what is the resistance I have connected with RB? With RB I have connected 4 ohms. So the point which I am picking up is the resistance which is applied over here. That means if I am picking 2 plus 2, that means here the total resistance is 9 ohms. Okay, now for this timing I'll apply only 4 ohms. So that is why these 2 and 2 will be removed. Rest of the key will be intact. Now my job is to find out a specific point of the length where the galvanometer will show no deflection. Now initially the galvanometer is showing very high deflection, so we have to control the current by reducing this rheostat. So we will reduce the current by using this rheostat. Now the galvanometer will not deflect much. And still now it's very difficult for me to find out the null point. The reason is why, because maybe some of the connection, some of the knobs is not tightened up properly. So I'll check. So this is another very important point where students do mistake. Okay, so I have to check every knob whether every knob are tightened up properly. Now once I have checked everything and everything is tightened up properly, I'll check the resistance box. Now the second mistake students generally do, they generally do not tighten up these keys, and that is the big mistake. Why? Because we want to apply 4 ohms, but somehow this 20, as you can see, this 20 knob is not tightened up properly. Okay, it's just like this, placed like this. It maybe seems to you that this knob is what is tightened up properly, but you have to tighten up by applying a very bit pressure. Okay. Now due to some errors, we have replaced this resistance box because that resistance box was sometimes faulty. As I said, although we try to make our apparatus is a good one, but sometimes it happens. So I have replaced this resistance box with a new one. Now let us see where the null point is coming. So I'll check. See, the galvanometer is showing the deflection in 330 here and here in the opposite direction. So our job is to find out a specific resistance, specific length where I get a null point. Okay, so here right and here left, so it will be somewhere in between over here. So we have to find out the length. So as you can see, at the length of 70.5, at the length of 70.5, the galvanometer is showing no deflection. You check
70.5.
70.5, the galvanometer is not showing any deflection. So we'll write over here. Here the 4 ohms is connected. See, here the 4 ohms is connected, and here the reading is 70.5. So we'll write 4 ohms 70.5. Okay. Now we'll increase it by 1 by removing 1 ohm. So the total resistance is 2 plus 2 plus 1, that means 5 ohms. Okay, so that is the total resistance. So let us see where the null point is shifted. So whenever I am increase the resistance in the left hand side, that means the known resistance, the null point must shift in the right hand side. Okay, so null point will shift in this direction. See, so as I can see, at 74.6 the galvanometer is showing zero deflection. Okay, 74.6. So I'll write 5 ohms 74.6. Okay, now I'll make it 3 ohms. Okay, so I'll just make it 3 ohms just by reducing 2. I'll connect these 2. So the total resistance is 1 plus 2, that is 3 ohms. Now let me check where the null point is shifted. Now I have reduced it by 2, so the null point will be shifted towards left. So let us check. So as you can see, at 64.3 the null point, the galvanometer is showing zero deflection. So we conclude that at 64.3 there should be a reading. So 3 ohms, for 3 ohms 64.3. Okay, now we'll make it suppose 2 ohms. Okay, so we'll just make it 2 ohms. We'll just remove 1. So now the reading is 2 ohms. Okay, you see the reading is 2 ohms because only 2 key is removed. So we'll check whether this null point is shifted towards left or not. So it is my expectation the null point will be over here or something around over here. So let us check. So as you can see, at 54.3, at 54.3 the null point is there. So 54.3. Okay, so we'll write for 2 ohms 54.3. okay, now we'll make it 1 ohm. We'll just go way around and just make it 1 ohms. Okay, so the reading must be shifted towards left. So let's check. So as you can see, at 39.2, the galvanometer is showing more or less zero deflection. Okay, so we'll write for 1 ohm it is 39.2. okay, so only 5 reading is sufficient. So rest of the calculation we'll do, and we'll check what is the unknown resistance. So after calculation of the unknown resistance, this is our job to find out the cross section. So in order to find out the cross section, we have to find out the diameter of this wire. So which wire? The wire we have used for making this unknown resistance. So we have to find out the diameter of this wire. Okay, so we'll take a sample wire of this wire, the same type of wire which the type of wire which I have used. So we'll take it and find out the diameter of this wire. Okay, so let us just find out the diameter. Okay, so this is the sample wire. This is the same type of wire which we have used for making this unknown resistance. Okay, so we'll not open it up, rather we take a sample wire. So this is the sample wire, and this is the device by which we are going to measure the diameter of the wire. So basically this is called screw gauge. Okay, so we'll just remove it, and this is the sample wire which we have, and we are going to measure the diameter of the wire. Now whenever you are going to measure the using the screw gauge, you have to find out the least count of the screw gauge. We already know what is the least count of the screw gauge, so that's why you are not doing it separately. So now the main scale reading is 0. So the main scale reading is 0, and the circular scale reading is 25. So 25, we'll take it again in a different position. Now the main scale reading is also 0, and the circular scale division is 26. Okay, as you can see here, the reading is 26. Okay, 26. Now we'll do it again. And here you can see the main scale reading is 0 and the circular scale reading is 24. Okay, so we'll write 24. The least count of this screw gauge is 0.01 mm. Okay, so we have to multiply with this least count with the circular scale reading, and we'll get the reading in mm to be true value to be 0.25, 0.26 and 0.24. We'll just calculate the mean of this and we have to find out the diameter of this sample wire. Okay, we have to find out the diameter of the sample wire, and then by calculation we can find out the resistivity of this wire by using this formula. So rest of the practical will do.
So after doing the practical, it is time to do the calculation. So first we will try to find out the 100 minus L for the 5 reading, and then by the calculation we will find out the X. Please follow the steps which I am following if you do not know how to do the calculation, or else you can do the calculation by your own. So please follow. Now as you can see, we have calculated the values of the unknown resistance, and the unknown resistance had come 1.67, 1.70, 1.66 and 1.68, and the last one is 1.55. So see the similarities in the reading of 4 data, but the one with 1 ohm resistance is actually some problematic. That's why it is giving 1.55. So however, we'll take the 5 reading and we'll find out the average.
So the average is coming 1.65 ohms. So we have to find out the average of 0.25, 0.24, 0.26, and the average of them is 0.25. Now let us try to find out the rho. First we have to convert that mm into meter by multiplying with 10 to the power minus 3, and we'll put the value over here, and we have to find out the value of the rho by the following steps. So first we'll write the formula in the copy, and we'll put the values of x, pi and d square in the formula, and we have to find out the value of the rho by the following steps. Please follow my steps, otherwise you can do the calculation by your own. So if the video is helpful to you, please let me know. Then I'll try to make lots of video like this. But make sure that these videos are helping you in your academic curriculum. So thank you for watching. Bye bye.